In this problem, we're told that David is at his office in City E and is considering adding new stores in locations A, B, C, and D. And he wants to visit each of those locations and return to his office in City E. So we're given the prices of one-way flights, and we want to create a complete weighted graph. So we have to choose which one of these three is the correct graph. And I'm going to start by looking at the cost of traveling from City A to City B, and that is $433. So when I check that on the three graphs, only one of them has $433. So that means that graph A is the correct graph. So now that we know what the complete weighted graph is, we can use the nearest neighbor method in order to find the least expensive route. So it says in part B, use the nearest neighbor method to approximate the optimal route. And so always keep in mind that this is an approximation. Maybe it's the best, but maybe not. So we need to start in City E. So A is definitely incorrect. Can eliminate that immediately. And we need to see what the least expensive route is going to be. So I'm going to enlarge our graph. So here we're looking at a larger version of the graph, and I need to determine which edges to travel along in order to visit every city and return to E. So we're starting in City E, and I need to look at all the costs of traveling to the other cities from City E. So I'm looking at $379, $501, $482, and $443. And I choose the cheapest of those, which is to go to City A. So I can eliminate the other ones. And we are going to travel from E to A. Now that I'm in City A, I want to see what is the cost of traveling to the remaining cities. So we have $433, $495, and $463. I can't go back to E immediately, so I ignore the $379. So the least expensive is $433. So that means we're headed to City B, and we forget the other ones. All right, so now that we're in City B, I'm going to look at the cost of traveling to City C, which is 100, and City D, which is 143. So City C is going to be the least expensive. And I eliminate D. And now I have to travel to City D. It doesn't matter how much it costs because that's the only city remaining. And then I have to go to City E. So we found the route. It's going to be to go from E to A to B to C to D and back to E. So that's this choice D. And then I calculate how much the total cost will be. So I add the $379, $433, $100, $549, and $443, and that gives me $1,904. So that's the cost of traveling through this route. So that's the nearest neighbor method. Is it the least expensive? Maybe, maybe not. We don't know. So now let's take a look at part C. This says to determine the cost of traveling the route from E to D. Okay, so that's for $443. And then we need to go to B. That's going to cost $143. And then to A. And then to C. So that's going to be $495. And then back to E, and that's going to cost $482. So let's see what that adds up to. So that cost is going to be $1,996, and that is greater than the cost that we determined through the nearest neighbor method. So that doesn't prove that the nearest neighbor method is the cheapest, but it's certainly cheaper than this method that they gave us. So, or the route that they gave us. So that's how you do that problem.